Hello everyone, you've made it to page 4, the last page of the Chapter 8 study guide. This last section deals with the perimeter and area ratios between similar figures. So notice that it starts within the directions, given the similar figures. The next set says the figures in each pair are similar. And then it says similar figures again. So all of this has to do with when figures are similar. And there are certain ratios that exist between the area and the perimeter of similar figures. So we want to find the similarity ratio. Similarity ratio, remember, is always going to be A over B. We want to find the perimeter ratio, which is going to be the exact same thing, same units, same ratio. But remember that area ratio is always going to be A squared over B squared, which is easy to remember simply because area is always in units squared. So we're going to find the similarity ratio, A over B, perimeter ratio, A over B, and the area ratio, A squared over B squared, between the two figures. So in number 50, they're both triangles. We were told that they're similar. So every single one of these problems, I'm told that these shapes are similar from the beginning, so I am able to create these relationships. And so what we're going to do is we're going to find the similarity ratio, and we're going to do that by comparing the two corresponding parts of the figures. So all I have in the picture is a piece of the bottom of one of the triangles, and that is going to correspond to the bottom of the other triangle. And so I can write a similarity ratio between these. They do not indicate which one they want me to do, left to right or right to left, so it can be written either way. A ratio typically can be written either way, but a scale factor is more specific. And they'd have to tell you which one is the old and which one is the new. But this, we're just comparing the two. So what we're going to do is we're going to say, okay, if I go left to right, that would be 8 over 6, which would simplify to 4/3. So the similarity ratio is 4 over 3, or you could even write that as 3 over 4 if you chose to. So what that means is even though I don't know the perimeter, remember perimeter would be the distance around the entire shape, but I don't know these other two sides, I can still find a perimeter ratio because it's going to be the exact same thing as the similarity ratio. So it's also going to be 4 over 3. To get the area ratio, I am not able to actually find the area because this is a right triangle, or it appears to be a right triangle, but it's a triangle, so the area would be 1/2 times the base times the height. Unfortunately, I don't know the height of the figure, but I can find the ratio between the two by doing A squared over B squared. So that's going to be 4 squared over 3 squared. 4 squared is 16, 3 squared is 9. So that's going to be 16 over 9. 4 over 3 is the perimeter ratio, and similarity ratio is 4 over 3. So it would be totally fine if you wrote this the other way, if you wrote 3 over 4, 3 over 4, and 9 over 16. All right, number 51, let's do the exact same thing. So we need to find A and B, we need a set of corresponding pieces. This part of the trapezoid corresponds to this part of the trapezoid. So let's say I chose to do 10 over 15. That would reduce to 2/3. So not only is that the similarity ratio, A over B, it's also the perimeter ratio. So both of those are A over B. The area ratio is going to be 2 squared over 3 squared, A squared over B squared. So that is going to be 4 over 9. So I've got 4 over 9 is the perimeter ratio, or the 4 over 9 is the area ratio, perimeter ratio is 2/3, and the similarity ratio is 2/3. Again, if you flip-flopped this, if you did 3/2, and 9/4, that would be totally fine as well. Because it says ratio, you can write it as left to right or right to left. They did not specify. All right, now this one's interesting. This one, all of a sudden, they do give you corresponding pieces. So watch, they give you the 4, they give you the 8. So same thing as before, 4 over 8 reduces to 1/2. So that is the similarity ratio. It's also the perimeter ratio, but they don't ask for the perimeter ratio this time. They immediately jump to asking for the area ratio, which is going to be 1 squared over 2 squared, which is equal to 1 over 4. You can actually use that to find the area of the larger triangle. So the area of the smaller triangle is 12. So let me do that in yellow. If the area of the smaller triangle is 12, how do I find the area of the bigger triangle? Well, 12 over larger triangle, the area, 12 over A, is going to be equal to the ratio of the area, which is 1/4. So I don't set that equal to 1/2, that's the similarity ratio. I set that equal to 1/4, because I know that the bigger area is going to be 4 times bigger in the ratio of 1 to 4. So you could either cross multiply this or just multiply 12 by 4. The area, when you do that, is going to be 48 inches squared. The area of the smaller was 12 inches squared. The area of the larger figure is going to be 48 inches squared. Okay, let's do that again. With this, we have the area of the larger pentagon this time. Area equals 135 centimeters squared. So we're going to want to find the area of the smaller figure. So let's first find the similarity ratio. So we're given a side of this pentagon, so 24 over 8. 24 over 8 is going to reduce to 3 over 1. So that is my similarity ratio as well as my perimeter ratio, but they did not ask for that. How am I going to find my area ratio? I'm going to do 3 squared over 1 squared. That's going to be 9 to 1. So how do I find my area? Well, if the one on the left is 9 over 1 times as big, and my area of the one on the left is 135, I can put that over A. So my actual area is 135 of the bigger one. I want to find my actual area of the smaller one. That's what I'm trying to find here. And we know that the bigger one is 9 times as big. So again, I'm just going to cross multiply. And so I'm going to do 135 divided by 9 whenever you cross multiply. 135 divided by 9 is 15. So the area of the smaller pentagon is 15 centimeters squared. So we're able to actually find a missing area using the ratios. All right, this next one does not have a picture, but it's interesting because it doesn't give you a picture, meaning it also doesn't give you corresponding pieces. So like in these triangles, I had corresponding pieces. All I'm given on this next one is a description where it says 2 regular polygons with areas 144 inches squared, or square inches. That means the same thing. So one has 144 inches squared of area. The other has 36 inches squared of area. So what are these values? These are not A and B. This is your A squared and your B squared. This is your A squared and your B squared. So I can put them in a ratio, 144 over 36. And 144 over 36 is going to be 12 over 3, which is 4 over 1. Let me double check that and make sure. 144 divided by 36 is 4. Okay? So my A squared over my B squared. A squared over my B squared is 4 over 1. That is my area ratio. It says given the area or perimeter of similar figures, actually go back and find the ratios. So if that is my area ratio, not ration, y'all, I'm sorry, ratio, how do I find my similarity ratio and how do I find my perimeter ratio? You just go backwards. If you're going from A over B to area, you square it. The inverse of squaring something is taking the square root. So if A squared over B squared is equal to 4 over 1, what we're going to do to get just A and B is we're going to take the square root of both of those. So we're going to take the square root of 4 over the square root of 1. Okay? Square root of 4 is 2, square root of 1 is 1. Not only is that my similarity ratio, that is also my perimeter ratio. Okay, so 2 over 1 is my similarity ratio and perimeter ratio. 4 over 1 would be my area ratio. So I have all three. Oh, they wanted us to fill it in here. I was wondering why I didn't have blanks for that. Hold on one second, y'all. So area ratio would be 4 over 1. Both of these would be 2 over 1. 2 over 1 and 2 over 1. Okay, again, where these two are always going to match. All right. So last but not least, we have a problem exactly like that, except they do have a picture, and instead of having the areas, they have the perimeters. So you could do this multiple ways, but let's say that you didn't have these pieces. You could easily find the similarity ratio. Because these are rectangles, you could easily find this, but let's pretend that these weren't here. How would you find the perimeter ratio? Well, I'm just going to do the perimeter of the small to the perimeter of the big. So that would be 32 over 48. When I reduce that, we can do, that is going to give you my A over my B. A over B. So I can divide both of these. Both of these are divisible by 4. And that would be 8 over 12, I believe. And I can reduce that again. Divided by 4 would be 2/3. So my A over my B would be 2 over 3. So where do I get to fill that in? I get to fill that in for the perimeter ratio and for the similarity ratio. We didn't have side lengths to find the similarity ratio immediately, but we were able to find the similarity ratio because they gave me the pieces of the perimeter, the total perimeter. If that is my similarity ratio, how do I find my area ratio? I take the 2 over the 3 and I square them both because this should be A squared over B squared. Both of these are A over B. Area ratio should be A squared over B squared, so that's going to be 4 over 9. Okay? So this was a little bit different because instead of giving you corresponding pieces, it gave you the actual perimeters, corresponding perimeters, and you wrote a ratio of those, and then you were able to find the area ratio. So that is the very last page. That is our Chapter 8 study guide. So come see me if you have any questions. I am happy to help you. It is my job to help you, and I enjoy helping you. I hope you have a wonderful day.